Hello there. Welcome to Sleep Lore, a quiet little corner in this vast universe. A place where curiosity meets calm, where science does not tense you up, but gently carries you towards sleep. Tonight, the story I want to share with you is a beautiful one. Beautiful in the way that lets your heart settle as you listen. It is the story of how galaxies, cities made of billions of stars, were born from darkness, from cosmic dust. I am going to take you back in time, not to a recent past like last week or last year, but to a very distant one, 13.8 billion years ago. A stretch of time that begins when the universe first came into existence and leads all the way to now. It sounds long, but do not worry. We will move slowly, with no rush at all. Those stars have been waiting for billions of years already, they can wait one more night for you. I know you may have had a long day. Maybe you are tired. Maybe your mind is still busy with work, with conversations, with tomorrow's to-do list. That is okay. All of that will still be there in the morning, it is not going anywhere. But tonight, for the next hour or two, you do not need to think about any of it. You only need to lie still, listen to my voice, and let your thoughts drift among the stars. I hope this story will not be so exciting that it keeps you awake all night. But if it does, at least you will know a little more about the early universe before you have your coffee tomorrow morning. That is not such a bad thing, is it? So, make yourself comfortable. Pull the blanket up a little if you feel cold, adjust your pillow until it feels just right, turn off the harsh lights, and set your phone aside. Now, are you ready? We are about to begin a journey 13.8 billion years long. From a moment when the universe was small, hot, and crowded, all the way to today, when it has become unimaginably vast. We will drift through darkness, through the first light, through the birth of stars, and finally into galaxies, enormous cities made of light. Maybe you've done this before, on a clear night far from city lights, you look up at the sky and see the stars. They shimmer like tiny diamonds scattered across a sheet of black velvet. Some shine brighter, some fade softly into the dark. Some glow white, others carry a hint of red, or a pale wash of blue. It's beautiful, isn't it? But what you're looking at, all of those stars, is only a very, very small part of the story. Every star you can see with your naked eye lives in the same neighborhood as we do. They are our cosmic neighbors. Together, we all share one enormous home, a vast structure we call the Milky Way. The Milky Way, our galaxy, contains somewhere between 200 and 400 billion stars. That number is so large it almost loses its meaning. Even if you live to be 100 years old, you could never count them all. Not even if you counted one star every second, without rest, without sleep, day and night, for your entire life. And yet, that is just one galaxy, one single home in an endless cosmic city. Now look farther, beyond the Milky Way, past our familiar neighbors and out into deep space. There are countless other galaxies, scattered like islands of light in a dark cosmic ocean. Each one holds billions, sometimes hundreds of billions of stars of its own. Some galaxies are larger than the Milky Way, some are smaller, but all of them shine. Scientists estimate that the universe contains around 2 trillion galaxies. 2 trillion. Take a moment to sit with that number. You cannot count it. You cannot truly picture it. Even when you try, your mind slips off the edge of its vastness. Each galaxy holds billions of stars. So how many stars are there in the entire universe? More than grains of sand on every beach, in every desert on Earth. So many that language itself runs out. This is the universe we live in, unimaginably vast, overflowing with stars, galaxies, and worlds beyond counting. But here's where the story becomes truly fascinating. All of those galaxies, all of those stars, they were not always there. Once, a very long time ago, there were no galaxies at all. No stars. No light. Only absolute darkness, cold, empty, and silent. So what happened? How did something emerge from nothing? How did darkness give way to light? How did emptiness turn into vast cities of stars? That is the question we're going to explore tonight. And this story isn't just about distant galaxies. It's also about us. Because everything you're touching right now, the warm blanket, the soft pillow, even your own body, was made by stars. The atoms that form you were forged in the hearts of stars that died long before Earth was ever born. Stars in distant galaxies that lived and died billions of years ago. You are a piece of the universe. A tiny piece, but a real one. Made of stardust, ancient light, and galaxies we are about to explore together. So when we look up at the night sky, when we peer into distant galaxies through telescopes, we are not only looking outward. We are also looking back into our own past. We are looking at our origin. But there is one question that almost everyone asks at least once in their life, young or old. Those galaxies, where did they come from? How were they born? Who, or what, created them? Did they simply appear on their own? Or is there a process, a recipe, a way the universe transforms chaos into order? The answer is surprisingly beautiful. It is simple, yet profound. Scientific, yet almost poetic. It is a story about time, gravity, light, and darkness. The story begins 13.8 billion years ago, when the universe was nothing like it is today. When it was small, smaller than a grain of sand, smaller than an atom. The universe began as a single point. A point unimaginably hot, impossibly dense. Holding everything that would one day become all that we see around us. And then, in a miraculous moment, a mysterious instant that even the greatest scientists still struggle to fully understand. The universe began to expand. That was the beginning of everything, the beginning of space, the beginning of time, the beginning of light, matter, and energy. The beginning of galaxies. The beginning of us. So now, let's turn back the clock together. Step by step, moment by moment, we'll travel into the past until we reach the place where everything began. Where darkness had not yet known light. Where silence had not yet been broken by the echo of the first star. Where the universe was still dreaming of what it would become. 13.8 billion years ago. That number is hard to wrap your head around, isn't it? A billion years is already a mind-bending stretch of time, but 13.8 billion, that's longer than anything we can truly imagine. Earth itself is only about 4.5 billion years old, and humanity has been around for just a few 100,000 years. Compared to 13.8 billion years, we're nothing more than a brief flash in an endless night. But let's try to go back, all the way back, to the very first moment when everything began. At that time, the universe looked nothing like anything you've ever seen. It wasn't a vast, dark, cold emptiness like the cosmos we picture today. Back then, the universe was incredibly small, so small that even the most powerful microscope imaginable wouldn't be able to see it. Smaller than a cell, smaller than an atom, smaller than the tiniest particles that make up atoms. The entire universe, everything that would one day become stars, galaxies, planets, you, me, every person, every object, all of it was squeezed into an unimaginably tiny space. Inside that minuscule volume, the universe was unimaginably hot. Hotter than anything that exists today, hotter than the core of the sun, hotter than a nuclear explosion, hotter than anything we can create or even measure. The temperature was so extreme that no form of matter as we know it could exist. No atoms, no molecules, not even the most basic particles had formed yet. The universe wasn't just hot, it was unbelievably dense, denser than metal, denser than rock, denser than anything we've ever encountered. Everything was crammed together, crushed into a wild, almost absurd density. That was the universe at the beginning, tiny, blazing hot, impossibly dense, containing everything. And then, something happened. A mysterious moment. A moment no one fully understands, no one knows exactly how it happened, or why. The universe began to expand. We call that moment the Big Bang. It sounds dramatic, doesn't it? But the name is a little misleading. Because it wasn't an explosion in the usual sense. When you hear the word explosion, you probably imagine a bomb going off, fragments flying outward through the air. Or a balloon popping, pieces of rubber shooting into the space around it. There's a center, and debris moves outward into space that already exists. The Big Bang wasn't like that. It wasn't an explosion in space, it was the expansion of space itself. That's a strange idea, so let's slow it down. Before the Big Bang, there was no outside space to explode into. There was no empty room waiting to be filled. There was nothing, and even the concept of nothing didn't really exist yet. Then space itself came into existence. It didn't expand into something else, it created itself as it expanded. Imagine inflating a balloon. Dots drawn on the surface of the balloon move farther apart as the balloon grows, but the dots themselves aren't crawling across the surface. The surface is stretching, and that stretching carries the dots away from each other. The universe works the same way. Space itself is stretching, and everything inside it is being pulled apart, not because things are moving through space, but because new space is forming between them. What's even more astonishing is the speed. The universe expanded at an incredible rate, faster than light, faster than anything we're familiar with. In the tiniest fractions of a second, intervals so short we barely have language to describe them, the universe swelled by many, many times its original size. This phase is called cosmic inflation. In less than the blink of an eye, shorter than a single heartbeat, the universe became vastly larger. From something smaller than an atom, it expanded into an enormous region of space. And space didn't stop being created. It's still being created, second by second. But space wasn't the only thing born in that moment. Time began then too. Before the Big Bang, there was no before and no after. There was no now or then. Time didn't exist. So asking what happened before the Big Bang doesn't really make sense, because there was no before. Time, like space, was born with the universe. That's why we say the universe is 13.8 billion years old. That's not time since the universe was created inside something else. It's time since time itself began to flow. Now, you might be wondering, why? Why did this happen? Who, or what, set the Big Bang in motion? These are questions the greatest scientists in the world are still trying to answer. The honest truth is, we don't know. We don't know why the Big Bang happened. We don't know whether there was anything before it, because the very idea of before may not apply. What we do know is that it happened. We can see its evidence everywhere. We can measure it, calculate it, trace the faint echoes left behind from that first moment. The universe has been telling us its story through light, through numbers, through ancient signals that still surround us. So in those first seconds, or more accurately, those tiny fractions of a second, what was happening inside this newborn universe? Chaos. Pure chaos. The universe was a boiling soup of the most fundamental particles. Particles so small we can't see them or touch them, yet they form the foundation of everything. Energy was so dense that it constantly transformed into matter, and matter dissolved right back into energy. Everything was changing, shifting, moving at insane speeds. Nothing was stable. Nothing was calm. Everything was a wild dance of creation. Hot, blindingly bright, chaotic, and overflowing with energy. That was the universe in its earliest moments, a place where nothing familiar could exist. No stars, no planets, no atoms, not even light as we understand it. Only raw, primordial energy, dancing and transforming, laying the groundwork for everything that would come later. It's hard to imagine, isn't it? A tiny universe, scorching hot, packed with energy, expanding at a breathtaking pace. No one was there to witness it. No eyes to see, no ears to hear. Just the universe itself, giving birth to itself, building itself, beginning its journey toward everything we see today. In those first moments, so much was decided. The laws of physics began to take shape. The fundamental forces of nature emerged. The blueprint for the future was sketched out. The universe was learning how to exist. Take a deep breath. The universe is still very young, and we've just watched its birth. But the story is far from over. There are countless wonders still ahead. In the moments that followed, the universe began to cool, slowly. And as it cooled, something magical started to happen. Tiny particles began to join together, forming larger, more complex structures. The first building blocks of the universe were being assembled. The universe is still expanding, but the very first moment has already passed. It begins to cool down, not cool as uncomfortable or pleasant. It is still unimaginably hot, but compared to its initial state, the temperature is slowly dropping. As the heat falls, something remarkable starts to happen. The universe begins to organize itself. In those first seconds, the universe is like an extremely thick, boiling soup, incredibly hot, filled with tiny things bouncing around in wild chaos. What are those things? We call them fundamental particles, the smallest building blocks of everything in the universe. There are particles called quarks, so small that even the most powerful microscope could never see them. They are like microscopic marbles, zipping around, crashing into one another non-stop. Quarks are not alone. They stick together thanks to another kind of particle, a sort of cosmic glue known as the gluon. Gluons hold quarks together like invisible strings, connecting and binding them, never letting the quarks drift too far apart. And then there is light, but not the kind of light we see every day. Not light from a bulb or from the sun. This is pure, primordial light that has never touched anything. These particles of light are called photons. They race around at the fastest speed possible, the speed of light, darting everywhere like overexcited children who cannot sit still. Photons have no mass at all. They are weightless, pure energy in motion. They bounce around, collide with quarks and other particles, then fly off again. The universe at this stage is dazzling, not dazzling in a way anyone could see, because no eyes exist yet. But it is overflowing with energy, flooded with light in constant motion. The temperature is still insane, reaching trillions of degrees, hotter than the core of any star that exists today. The pressure is equally unimaginable. Everything is squeezed together, crowded and compressed into a space that is still relatively small, even though it is expanding every second. This is a brutal environment. Not a place for life, not a place for calm. Everything is chaos, energy, relentless motion. And yet, within all this turmoil, something quiet is at work. A force that is weak but patient, a force that will shape the future of everything. Gravity. Gravity is not loud. It does not shine like photons. It does not bind fiercely like gluons. Gravity is incredibly weak, far weaker than the other forces. But gravity has one advantage. It never gives up. It always pulls, always acts, never cancels itself out. Wherever there is mass, wherever there is matter, gravity is there. In this young universe, gravity is watching, waiting for its moment. It notices places where matter is just a little denser, where particles are slightly more crowded. These tiny differences, these barely thicker spots, will matter later. They will become the birthplaces of galaxies and stars. For now, gravity simply waits, patient and silent, like an artist sketching the first faint lines on a blank page. The universe keeps cooling, and as the temperature drops, quarks begin to combine in new ways. 3 quarks can stick together, forming something larger. When 3 quarks bond in the right configuration, they create what we call protons and neutrons. The names sound technical, but in truth, they are just small groups of quarks clinging tightly to one another. Protons and neutrons are important because they will later form the core of every atom. They will become everything we see, touch, and feel. But the universe is still far too hot and violent. Newly formed protons and neutrons are smashed apart by energetic photons. Everything is still a battlefield. One particle slams into another. Energy turns into matter, matter dissolves back into energy. Nothing is stable. Nothing lasts. Yet the universe is learning. It is experimenting, searching for ways these particles can stay together, can grow into something bigger and more complex. In our world, 3 seconds pass in the blink of an eye. But in the newborn universe, 3 seconds are a long time, long enough for change to happen. About 3 minutes after the universe begins, the temperature has dropped enough to no longer be utterly insane. Now protons, positively charged particles, begin to capture others. They pull neutrons close and hold on to them. A lone proton becomes the nucleus of the simplest, lightest atom. We call it hydrogen. Hydrogen. It sounds familiar. It is the gas that becomes water when it bonds with oxygen. But right now, it is just a single, lonely proton drifting through a scorching universe. Some protons do not want to be alone. They find companions. A proton joins with a neutron, and sometimes another proton, another neutron. When 2 protons and 2 neutrons bind together, they form the nucleus of a slightly heavier atom, one we call helium. Helium. Another familiar name. The gas that makes balloons float. The gas that makes voices sound funny when you breathe it in. But in the early universe, it is a major achievement, a critical step forward. Hydrogen and helium are the first 2 elements, the first building blocks of the universe. That is it. Just 2. In those first minutes, the universe can only make hydrogen and helium. There is a tiny amount of lithium, the third element, but it is so rare it barely matters. There is no carbon, no oxygen, no iron, no gold, no heavy elements at all. Those will have to wait. They will be forged later, inside the first stars. For now, the universe contains only hydrogen and helium, the simplest and lightest building blocks. They are like the most basic pieces in a box of building toys, the pieces you need before you can construct anything else. Do not underestimate these simple blocks. From them, everything will be built. Hydrogen and helium will gather into enormous clouds. Gravity will pull them inward, compressing them until they become hot and dense enough to ignite into the first stars. Inside those stars, hydrogen will turn into helium. Helium will turn into carbon. Carbon into oxygen. Oxygen into heavier elements, layer by layer, until there are enough ingredients to make planets, oceans, trees, and people. Everything begins here, with hydrogen and helium, with 2 simple blocks formed in the first 3 minutes of the universe. Think about that. In just 3 minutes, the universe goes from pure chaos to creating the fundamental ingredients of everything. 3 minutes, shorter than the time it takes to boil water for tea, shorter than a song. Yet in those 3 minutes, the foundation of the future is laid. Protons, neutrons, electrons, photons. Hydrogen and helium. All are now present. What the universe needs next is time. Time to cool further. Time for these building blocks to come together. Time for gravity to do its work. The universe is still expanding, but now it has the basics. It is like a kitchen stocked with ingredients. Flour, sugar, eggs. All that is left is time, the right temperature, and a little patience to bake a cake. The universe is the same. It has hydrogen. It has helium. It has gravity. It has time. Now it waits for the temperature to drop even more, for everything to settle. It waits for these building blocks to find one another and combine into something more extraordinary. Take a deep breath, feel your breathing, slow and steady. The universe is breathing too. Expanding, cooling, calming down. The early days of chaos are over. Now comes the waiting. Gravity works quietly. Photons still dart everywhere. Hydrogen and helium drift and spread through space. Everything is ready. Ready for something more beautiful, more complex, more miraculous. Ready for light. Ready for stars. ready for galaxies. But before we get there, the universe still has one more step to take. $380,000 years. That is how much time had passed since the universe began. For us, it is an almost impossible span to truly grasp. Humanity itself has existed for only a few 100,000 years. But on the cosmic timescale, 380,000 years is nothing more than a blink, a shallow breath, a fleeting moment. Scientists often say that compared to the universe's current age of 13.8 billion years, those first 380,000 years are like the first 3 days in the life of someone who lives to be 80. The universe's childhood. Its earliest days. Its very first steps. During all that time, the universe kept expanding. Space itself was still being created, day after day, year after year. As space expanded, everything inside it became thinner, more spread out. Particles drifted farther apart. Like dots drawn on a balloon, moving away from each other as you blow it up. As things spread out, the temperature dropped, slowly but inevitably. The universe cooled from billions of degrees, to millions, then to thousands. It was still unimaginably hot, hotter than any furnace on Earth. But compared to the beginning, it had already cooled dramatically. Throughout this era, the universe was filled with the nuclei of hydrogen and helium. Lone protons. Proton-neutron pairs tightly bound together. But something crucial was missing. One final piece needed to build a complete atom. The electron. Electrons are tiny particles with a negative charge, darting around atomic nuclei. They are much lighter than protons, yet absolutely essential. Without electrons, you cannot have real atoms. Electrons were created in the very earliest moments. But there was a problem. The universe was far too hot. Every time an electron tried to stick to a photon would come crashing in, knocking it loose. It was like trying to catch a butterfly in a storm. Just as your fingers are about to touch it, a gust of wind blows it away. And so electrons kept flying freely, unable to bind to any nucleus. But after 380,000 years, something changed. The universe had cooled enough, to about 3,000 degrees. Still as hot as molten metal, but no longer hot enough to prevent electrons from settling down. Now, when an electron drifted close to a proton, the electromagnetic force pulled them together. The electron slipped into orbit around the proton and stayed there. Photons still came flying by, but they no longer carried enough energy to tear them apart. For the first time in cosmic history, real, complete atoms formed. A proton captured an electron and became a stable, electrically neutral hydrogen atom. A helium nucleus captured 2 electrons and became a complete helium atom. A final handshake. A perfect union. Scientists call this moment recombination. A dry name, but one with a beautiful meaning. It marks the moment when the universe transformed from a chaotic cloud of free particles into a world of complete atoms, from disorder to structure, from fragments to wholeness. But something even more extraordinary was about to happen. Do you remember the photons, the particles of light bouncing everywhere? Before this moment, they could not travel far. They would fly a short distance, crash into a free electron, bounce off in another direction, then hit another electron. The universe was like a thick fog. Light could not pass through. It was trapped, endlessly scattered in a tangled web of particles. But now, the electrons were bound to nuclei. They were no longer free to roam. They had homes. They were anchored to their protons. Which meant the path was suddenly clear. For the first time since the universe began, light could travel freely. Photons streamed outward, no longer blocked, no longer deflected. They moved straight ahead, crossing thousands of light years, then millions of light years, without resistance. For the first time, the universe became transparent. The fog lifted. The curtain was pulled aside. Light was set free. That moment, the moment light escaped, is one of the most beautiful moments in cosmic history. It is like opening a window after a long storm. Fresh air rushes in. Sunlight touches your face. You take a deep breath and feel relief. The universe did the same. It exhaled, opening itself so light could run free. Those photons, released in that miraculous instant, are still traveling through the universe today. They have come a long way. Nearly 13.8 billion years, crossing expanding space. Passing through regions that would become galaxies, through clouds of gas that would ignite into stars, through darkness and brilliance alike. That light is still here. We can see it right now, at this very moment. Scientists call it the cosmic microwave background. A long name, but in truth, it is simply the oldest light we can observe. Light from the universe's infancy. This radiation surrounds us everywhere. Right now, as you lie here listening to my voice, photons released 380,000 years after the beginning of the universe are passing through your body. You cannot feel them. Your eyes cannot see them. Over all that time, as the universe expanded, the light stretched with it. Its wavelength grew longer. At first, it was visible light, perhaps a deep orange-red, glowing like a sunset. But after nearly 13.8 billion years, it has shifted into microwaves, a kind of radiation invisible to human eyes. Scientists, however, can see it. They use special antennas and powerful telescopes to capture these faint signals. When they observe the cosmic microwave background, they are looking into the past. They are seeing the universe as it was at 380,000 years old. They are seeing light from the moment it was released. Isn't that astonishing? Light from the universe's childhood is still here. It has traveled through all of history, through the birth of the first stars, through the formation of galaxies, through the creation of the sun and the earth, through everything. Now it surrounds us, like a delicate mist from a distant past. Scientists treasure this radiation because it is like a baby picture of the universe. A snapshot we can study, analyze, and learn from. By examining it, they can determine how hot the universe was back then. Which regions were slightly denser, which were slightly emptier. Tiny ripples in density that would later grow into galaxies. It is like reading the universe's diary. A diary written in light. Imagine this for a moment. What if your eyes could see microwaves? What if you could see this light the way you see ordinary light? You would look up at the sky and see more than just twinkling stars. The entire sky, in every direction, would glow with a gentle, warm, steady light. The night would never be truly dark. It would shimmer with a faint orange-red hue, like embers glowing everywhere. There would be no dark corners. No escape from that light. That is the light from the moment the universe became transparent. Light from the first time photons were free. Light from 380,000 years after everything began. The entire sky would be a painting of the distant past. A painting always present, always surrounding us, yet invisible to the naked eye. And remarkably, scientists have already captured this picture. They have mapped the cosmic microwave background. When you look at that map, you see patches of color. Red here. Blue there. These are not just pretty patterns. They are a map of the early universe. Red regions are slightly warmer. Blue regions are slightly cooler. The differences are tiny, only fractions of a degree. But they represent ripples, small fluctuations in the density of matter. Those ripples are the seeds of future galaxies. In slightly denser regions, gravity began pulling in more matter. Over time, these regions grew into vast clouds, then into clusters of stars, and eventually into galaxies. So when you look at the cosmic microwave background, you are not only looking into the past. You are also seeing the future taking shape. You are seeing the first seeds of everything that would come later. The universe exhaled in that moment. After 380,000 years of patient waiting, it finally let light escape. It was a turning point. A major milestone. From then on, the universe was no longer a dense fog. It was transparent. Light could travel far. Information could spread. Everything could, in a sense, see everything else. And yet, even though the universe was transparent, it was still dark. There were no stars yet. No galaxies. Only ancient light from recombination, slowly fading, slowly cooling. The universe was now a vast space filled with hydrogen and helium. Transparent, but dark. Quiet. Waiting. Gravity continued its slow, patient work, drawing gas clouds closer together, building denser regions in preparation for what came next. The universe had entered a long phase, one scientists call the cosmic dark ages. It sounds ominous, but do not worry. It is just a name. There were no knights or castles, only hundreds of millions of years without starlight. But in that darkness, something extraordinary was being prepared. Gravity was silently weaving the universe's structure. Gas clouds were gathering. The seeds of the first stars were beginning to sprout. Light had been released. Now the universe was waiting for new light. Light from the stars. Hundreds of millions of years passed. The universe remained dark and quiet, but not hopeless. Because in that darkness, something was beginning. Pure darkness. Absolute. Not a single trace of light. That is what you would see if you could travel back to the universe at that time. After the moment when light was released, after the ancient photons had long since flown away, the universe fell into darkness. There were no stars to shine. No suns to provide warmth. No galaxies glittering in the distance. Only darkness. Darkness everywhere, in every direction, without boundaries, without an end. Scientists call this era the cosmic dark ages. A name that sounds ominous. But there were no knights on horseback here, no castles. Only darkness, stretching on for hundreds of millions of years. The universe then was like an endless ocean, without shores, without a bottom. But instead of water, it was filled with hydrogen and helium gas. The simplest, lightest atoms, drifting through space like invisible mist. These atoms spread throughout space, like a thin blanket laid across the universe. They did not glow. They simply existed, quietly, in the dark. Imagine yourself floating in infinite space. All around you, in every direction, there is only black. Not the black you see when you turn off the lights in a room. Not the black of a moonless night. This is a kind of black you have never seen before. Black with not even the faintest hint of light. You cannot see your hands. You cannot see anything at all. Because there is nothing to see. No light source, near or far. Now and then, a hydrogen atom drifts by. Then another. Then a small cluster of helium atoms. They are invisible, colorless, odorless, silent. Just tiny particles moving slowly through space. You could reach out your hand, but you would touch nothing. The atoms are far apart, the space between them vast. You could travel thousands, millions of miles without colliding with anything meaningful. Silence is what you would hear. Or rather, what you would not hear. There is no sound at all. Sound needs air to travel, it needs molecules colliding to form waves. But here, the atoms are too sparse. They are so far apart that sound cannot exist. No wind. No waves. No birdsong or rustling leaves. No whispers. No breathing. Only silence, absolute silence. Silence so deep that you would hear the blood moving through your body. Your heartbeat. The sounds from inside yourself, because there is nothing left from the outside. The universe is silent like a deep sleep. Like the moment when everything has settled, when even breathing becomes so light it is barely noticeable. The universe is also very cold. It has cooled dramatically since its fiery beginnings. The temperature has dropped to just a few dozen degrees above absolute zero. Around minus 240-something degrees Celsius. Colder than any winter on Earth. Colder than Antarctica. Colder than the highest mountain peaks. So cold that everything nearly stands still. So cold that atoms vibrate only faintly, barely moving at all. But it is not the biting cold of winter wind. There is no wind here. Only the absence of heat. The absence of energy. A quiet kind of cold. Empty. Like standing too long in an unheated room, slowly going numb, losing warmth, but without pain. Just emptiness. In that darkness, in that silence, in that cold, time passes. But what does time even mean when nothing changes? When everything looks the same, day after day, year after year. There is no sunrise to mark a new day. No sunset to end the old one. No spring, summer, autumn, or winter. No cycles at all. Only drifting. The constant expansion of space. Atoms moving farther apart. The universe growing larger, with no one to measure it, no one to keep records. Time still flows, but it flows like a very slow river in the dark. You know it is moving, but you cannot see it. You cannot feel each second, each minute passing. 1,000,000 years go by. 10 million years. 100 million years. The numbers become meaningless. Because throughout all that time, everything looks almost the same. Darkness still reigns. Silence remains absolute. Hydrogen and helium continue to drift. A swimmer once said that when you swim in a pool that is completely dark, when you cannot see the lane lines or the walls, you lose your sense of direction. You do not know where you are swimming. You do not know how far you have gone. You only know that you are moving, but not toward what, or for how long. The universe is the same, floating within its own existence, with no markers to define it. Only the endless extension of darkness. But the universe is not completely empty. Even without starlight, even without anything glowing, things are still happening. Very slowly, very subtly, but importantly. This is gravity. That weak, patient force is still at work. Never resting. Never forgetting. It is pulling hydrogen atoms closer together. Slowly, bit by bit, forming delicate clouds that begin to gather. Not fast. Not loud. Just a quiet accumulation, unseen in absolute darkness. Places with slightly more matter, even just a little, begin to pull in more matter. Like a tiny, feeble magnet that never stops tugging, never stops attracting. The gas clouds begin to grow. Very slowly. One atom here, another there. Day after day, year after century, century after millennium. In the darkness, in the silence, the universe is preparing. This is not dead time. Not meaningless time. This is incubation. Waiting. Like a seed lying underground during winter. On the surface, everything looks cold, empty, lifeless. No green leaves. No flowers. But beneath the soil, the seed is quietly waking up. Roots begin to push downward. A sprout begins to rise. Slowly, patiently, without hurry. When spring arrives, the seed will break through the soil, stretch upward, unfold its leaves, and bloom. But all of that magic begins in the darkness of winter, in the silence of deep earth. The universe is the same. During the dark ages, through hundreds of millions of shadowed years, it is preparing for something extraordinary. The seeds of the first stars are being planted. Gas clouds are gathering. Gravity is weaving the foundation for future galaxies. There is no one there to witness it. No eyes to see. No ears to hear. Only the universe, alone with itself, in the dark, slowly reorganizing itself. It is a kind of loneliness that is hard to describe, but perhaps it is not a sad one. Perhaps it is a profound calm. A stillness before the storm. A long breath held before the universe exhales light. In that endless ocean of hydrogen, in that shoreless sea of darkness, everything drifts. Drifting without knowing its destination. Without knowing time. Drifting like vague dreams, unclear, shapeless. Sometimes, in life, we pass through periods like this too. Dark times when we do not know what comes next, when it feels like everything is standing still, not moving forward, not changing. But maybe, beneath the surface, something is happening. Maybe we are gathering strength, preparing for a leap, allowing small pieces to find each other, to connect, before bursting into something radiant. The universe teaches us that brilliance is not always required. Noise is not always necessary. Sometimes, the greatest things are prepared in silence. The universe during the Dark Ages was not afraid of the darkness. It accepted that time and used it to prepare for what was coming. It waited patiently through hundreds of millions of years in the dark. Now, it is ready for light to return. But not light from the past. Not the ancient photons from the moment of recombination. This will be new light, born from fire, from heat, from the heart of a star. Before we go on, there is a small secret the universe has been hiding in the darkness, ever since the very first moments, when the universe had just begun to expand. Do you remember the era of explosive expansion? When the universe ballooned from something smaller than an atom into something vast, at a mind-bending speed, in less than a second? In that extraordinary moment, something strange happened, something that even scientists had to think about for a very long time to fully understand. Tiny ripples appeared in the very fabric of space itself, smaller than atoms, smaller even than fundamental particles. Scientists call them quantum fluctuations. The world at the smallest scales is never completely still. It is always vibrating, always filled with tiny, unpredictable disturbances. Like the surface of a pond on a windless day, it looks calm at first glance, but in reality it is alive with countless microscopic ripples and subtle motions. Under normal conditions, these tiny fluctuations do not matter much. They appear and vanish without leaving any trace. But in the universe's first moments, when everything was expanding at an unbelievable rate, those tiny fluctuations were stretched out. Imagine drawing small dots on a balloon, then blowing it up. The dots suddenly become larger and farther apart. Those minuscule quantum ripples were stretched into larger variations, spread across the young universe. They were not matter, and they were not particles. They were simply regions of space that were ever so slightly different from one another. The differences were incredibly small. If one region contained 100 atoms, a neighboring region might have 99 or 101. A difference of 1 part in 10,000, 1 part in a million, so small it was almost meaningless. But gravity never ignores anything. Wherever there is even a tiny bit more matter, gravity begins to pull. In regions with slightly more matter, gravity pulls a little more strongly, drawing in additional matter from nearby. In regions with less matter, gravity is weaker, and matter tends to drift away, pulled toward denser areas. Over time, dense regions grow denser, and empty regions grow emptier. This process unfolds very slowly. In the early years, the differences were nearly invisible. Over hundreds of years, thousands of years, they were still hard to notice. But time kept moving, and gravity worked patiently, carving patterns and structures into the universe, slowly but relentlessly. During the cosmic dark ages, when the universe was shrouded in darkness, those tiny ripples were quietly growing. Slightly denser regions began to turn into clouds. Small, fragile clouds, but clouds nonetheless. Hydrogen and helium atoms gathered together, not by much, just a little more than their surroundings. The emptier regions became even emptier. Atoms left those areas, pulled toward the forming clouds. The original ripples, those tiny fluctuations from the era of explosive expansion, had now become a map of the future. Where the ripples were positive, where matter was just a bit denser, galaxies would one day be born. Where the ripples were negative, where matter was more sparse, vast voids would form, the quiet, empty regions of the cosmos. The future was seated in the distant past. What would happen billions of years later was sketched out in the first microseconds. That is the miracle. The smallest, most unpredictable random fluctuations at the quantum level determined where galaxies would form, and where we would eventually exist. There was no design, no plan. Only randomness, amplified, shaped by gravity over time. But how did scientists discover these ripples? They looked at the cosmic microwave background, the ancient light we talked about earlier, light from about 380,000 years after the universe began. When they mapped that radiation, they saw spots, regions that were slightly warmer and slightly cooler. The differences were tiny, just thousandths of a degree, but they were there. The warmer spots marked regions with more matter. The cooler spots marked regions with less. These were the fingerprints of the original quantum ripples, preserved in ancient light, like a photograph of the universe as a baby, revealing the seeds of the future. When scientists compared that map to the locations of galaxies today, they found a clear connection. Regions that showed warm spots in the past, where matter was slightly denser, have since become massive clusters of galaxies. Tiny ripples grew, over billions of years, into colossal structures. What does this mean for us? It means that our existence here, on this Earth, in this Milky Way, began with a minuscule random fluctuation in the universe's first microseconds. A tiny ripple. A microscopic disturbance. If it had not happened in just the right place, at just the right time, the Milky Way might never have formed. The Sun would not have been born. Earth would not exist. We would not be here. But it did happen. A small fluctuation, stretched by the expansion of the universe, nurtured by gravity over hundreds of millions of years, eventually led to us. We are the descendants of a quantum ripple. It is hard to grasp, isn't it? From something unimaginably small to something vast enough to span the universe. From a random vibration to galaxies, stars, and life itself. This is the power of time, of patience, of gravity always pulling, never forgetting, never giving up. During the cosmic dark ages, those ripples continued to grow day by day. Gas clouds became denser, gravity grew stronger, and the contrast between dense regions and empty ones became clearer. The universe was organizing itself, laying the groundwork for what was to come, with no guiding hand, no blueprint, only simple but powerful natural laws at work. The tiny quantum ripples from hundreds of millions of years earlier had completed their task. They showed gravity where to focus, where to build the cradles of new light. Now gravity had gathered enough matter, compressed it tightly enough, and created the necessary conditions. The rest belonged to fire, to light, and to the first star. The universe was breathing, ready for its most extraordinary moment yet. The moment when the first star awakened. Before we continue the story of the first stars, I need to tell you about a mysterious character. One that has been there from the very beginning, yet no one can see it. Not because it is hiding, not because it is too small, but because its very nature makes it impossible to see. It is dark matter. Dark matter. The name sounds mysterious, like something straight out of a science fiction movie, a dark force, a ghostly energy. But in truth, it is not scary at all. It is simply quiet, so quiet that it took us decades to even realize it exists. Dark matter is a special kind of matter. It is unlike anything we have ever touched, ever seen, or ever studied directly. Your eyes cannot see it. Telescopes cannot catch it. Even the most sophisticated instruments cannot detect it directly. It is completely invisible. So why do we know it exists? Because even though it is invisible, it still has mass, and mass means gravity. Gravity is the only way dark matter interacts with the universe around it. It is like the wind. You cannot see the wind itself, only what it does. Leaves rustle, branches sway, clouds drift across the sky. Dark matter works the same way. We do not see it, but we see its gravity pulling on everything around it. We see its fingerprints all across the universe. The story of discovering dark matter began with something strange. Scientists were observing stars at the outer edges of galaxies. They wanted to measure how fast those stars were orbiting around the galactic center. According to calculations, stars farther from the center, where there are fewer stars and less matter, should orbit more slowly, just like Neptune moves more slowly around the Sun. That is how gravity normally works. But when they made the measurements, they found something unbelievable. The stars at the edges of galaxies were moving incredibly fast, so fast that, according to theory, they should have been flung out of the galaxy entirely. Like spinning a plate too quickly, the marbles on it should fly off. But the stars stayed. They kept orbiting steadily, loyal to their galaxies. Why? There was only one possible explanation. There had to be much more matter than we could see. Matter that was not made of stars or gas. Not anything visible at all. But it had to be there, because its gravity was holding those stars in place. That invisible matter was dark matter. It surrounds every galaxy like a massive, unseen halo. An enormous bubble of matter we cannot see, yet one that holds everything together through gravity. And now comes the truly astonishing part. When scientists started adding up the numbers, they realized that dark matter was not just a small extra ingredient. There was far more of it than ordinary matter. In the universe, the matter we can see, stars, planets, gas, dust, everything that shines or reflects light, makes up only about 15% of all matter. 15%. That is it. The remaining 85% is dark matter. Invisible. Mysterious. Dominant. Which means that most of the matter in the universe is something we cannot see. When you look up at the night sky and see the glittering stars and distant galaxies, you are only seeing a tiny fraction of the full story. Most of what is out there is invisible, silent, yet it is holding everything together. It is like an iceberg. The part you see above the water is only a small piece. Most of it lies hidden below the surface, unseen, yet that is the part that truly matters, the part that keeps the iceberg intact. Dark matter is the hidden part of the universe. Bigger, heavier, more important than what we can see, yet always concealed. So what is dark matter? What is it made of? That is one of the biggest questions in modern science. It could be made of strange particles we have never detected before. It could be an entirely new form of matter, unlike anything we know. Scientists are searching for it. They build incredibly sensitive experiments deep underground, in the quietest places on Earth, hoping to catch a dark matter particle as it passes by. They observe the universe, looking for its presence in the way it bends light from distant stars. But so far, dark matter keeps its secret. It remains a mystery. A puzzle we have not yet solved. Still, even if we do not know what it is, we know what it does. Dark matter is the silent architect of the universe. In the earliest days, when the universe was filled with hydrogen and helium gas, dark matter was already there. It began clumping together under its own gravity, even before hydrogen started to gather. Dark matter created the skeleton of the universe, like an invisible web stretching across space. Where the web was denser, gravity was stronger. Those regions pulled in hydrogen and helium gas. Where does ordinary gas gather? Wherever dark matter has already prepared the place. Like guests arriving at a party and sitting in chairs that were set out in advance. Without dark matter, galaxies could not form. Hydrogen and helium alone do not have enough mass to clump together. Their gravity is too weak. They would simply drift and spread out, never becoming dense enough to ignite stars. But dark matter has mass, a lot of it. Its gravity is strong. It pulls gas into deep gravitational wells. It holds it there. It creates the conditions that allow gas to compress, to become dense enough for stars to be born. Dark matter is the pathfinder, the space maker, the one that clears the way for light to exist. Imagine you are building a house. You cannot just stack bricks right away. You need a frame, a structure of steel or wood to hold everything in place. That frame is not the beautiful part of the house. When the house is finished, you no longer see it. It hides behind walls, paint, and furniture. But without the frame, the house would collapse. Dark matter is the frame of the universe. It does not shine. It is not flashy. It does not call attention to itself. But without it, there would be no galaxies, no stars, no us. Every galaxy we see sits inside a vast halo of dark matter. That halo is much larger than the galaxy itself, extending far beyond the outermost stars. The Milky Way, our own galaxy, is swimming inside a bubble of dark matter. That bubble outweighs all the stars, planets, gas, and dust in the galaxy combined. We are living inside dark matter. It surrounds us. Right now, billions of dark matter particles may be passing through your body. But you do not feel them. They do not touch you. They simply pass through, silent as ghosts. Dark matter teaches us a beautiful lesson. Not everything important has to be seen. Not everything powerful has to be loud. Sometimes, the most important things are the quiet ones. Hidden. Humble. Like the foundation of a building. Like the roots that hold a tree upright. Like the quiet love of family. Things that do not show off, yet keep everything together. Dark matter is the universe's quiet love. Always present, always supporting, always preventing everything from falling apart. During the cosmic dark ages, when the universe was still wrapped in darkness, dark matter was working tirelessly. It was weaving the cosmic web, long filaments of dark matter stretching through space. Where those filaments intersected, knots formed, places where gravity was strongest. Those were the regions where hydrogen and helium gathered most densely. Those were the places where the first galaxies were born. So every time you look up at the night sky and see the stars and galaxies, remember this. They exist only because something invisible is embracing them, holding them, loving them with gravity. Now try to look at the universe from far away, not from Earth gazing up at the night sky, not from within the solar system looking out at the galaxy, but from outside everything. From a place where you can see the whole universe at once, like looking down at a vast cosmic painting. What you would see is hard to put into words. The universe is not a smooth, uniform space with galaxies sprinkled around at random. It has an intricate, complex, breathtaking structure. It looks like a gigantic spider web stretching across the cosmos. But not a flat web. This is a three-dimensional web, with filaments running in every direction, up and down, left and right, at every angle, forming a structure so complex it's almost unbelievable. Scientists call it the cosmic web. This web is made of dark matter, of hydrogen and helium gas, of gravity pulling everything together along invisible paths. Some of its filaments stretch for hundreds of millions of light years. These filaments are the cosmic highways, places where matter gathers, where galaxies line up, forming chains and vast structures. There are nodes too, intersections where many filaments meet. Here, gravity is strongest and matter piles up most densely. These become the great cities of the universe, enormous clusters of galaxies. But the most striking feature isn't the filaments, and it isn't the nodes. It's the emptiness. Between the filaments lie enormous regions that are almost completely empty. Places where gravity has pulled matter away, dragging it into the surrounding strands. These regions are called cosmic voids, vast hollows, lonely expanses. Some voids are hundreds of millions of light years across, so large they're hard to imagine. Inside them, there is almost nothing. No galaxies, no stars. Just a few lonely hydrogen atoms drifting through the darkness. The cosmic web did not appear by chance. It was seeded by the tiny quantum ripples we talked about earlier. Minuscule fluctuations from the era of explosive expansion sketched the universe's first blueprint. Then dark matter, with its quiet but relentless gravity, turned that sketch into reality. Over hundreds of millions of years, it pulled matter along predetermined paths. Slowly, patiently, without hurry. Where there was more dark matter, gravity was stronger. Hydrogen and helium were drawn in, and dense filaments took shape. Where there was less dark matter, gravity was weak. Gas was pulled away, flowing toward regions of stronger pull, and vast voids were born. And so the universe organized itself, arranging itself into a pattern, an architecture, a work of cosmic art. The cosmic web is the largest structure in the universe. Even galaxies, enormous as they are just tiny beads strung along its filaments. We, together with the Milky Way, are just one small speck on a single strand of that immense web. Think about that. Everything we know, Earth, the solar system, hundreds of billions of stars in our galaxy, all of it is just a tiny point on one filament of something far larger than we can truly grasp. That is the scale of the universe. That is the humility it teaches us. But the cosmic web isn't just beautiful in form. It's functional too. Its filaments are where galaxies are born, the highways along which matter flows, gathers, and builds star systems. The nodes are centers of activity, places where galaxies crowd together, interact, collide, and merge. The voids are regions of quiet, where little happens, where the universe seems to rest. The cosmic web reminds us that everything is connected. Nothing exists in isolation. Every galaxy, every star, every planet is part of something larger. So are we. We are not isolated islands. We are nodes in an invisible web of relationships, connections, and emotions. The universe teaches us about connection, about how everything matters. Big or small, everything plays a role in the greater picture. The universe has been waiting patiently. The web has been woven. Darkness has stretched across hundreds of millions of years. And now, deep inside a cloud of gas, at some node of the cosmic web, something is about to happen. Somewhere, in the endless darkness of the young universe, there was a cloud. This cloud was nothing like the white clouds in our sky. It was not soft or fluffy, not something you could see drifting overhead. It was invisible, a vast collection of trillions upon trillions of hydrogen and helium atoms, floating through the cold emptiness of space. The cloud was enormous, many times larger than our entire solar system. And yet, compared to the vastness of the universe, it was still just a tiny speck. Gravity slowly pulled it together over millions of years. One atom at a time, the cloud grew larger and denser. As the atoms moved closer, they collided more often. Each collision produced a tiny bit of heat. Over thousands of years, the cloud began to change. What started as a thin, cold gas gradually became something denser, hotter, more compact. At the center of the cloud, where gravity was strongest and matter most tightly packed, the pressure became overwhelming. Hydrogen atoms were squeezed together with unimaginable force. They had nowhere left to go. They were pushed closer and closer. Under normal conditions, atoms do not want to touch. Their electric charges make them repel one another. But here, the pressure was too great. The hydrogen atoms were forced together, whether they liked it or not. The temperature at the core skyrocketed, hotter than anything that existed during the cosmic dark ages. Hotter than almost anything since the first few minutes after the universe was born. At around 10 million degrees, hydrogen nuclei, lonely protons, were pushed so close together that they could no longer keep their distance. The electric repulsion weakened, and the strong nuclear force, the force that binds particles together, began to take over. Two hydrogen nuclei collided. They stuck. They fused into a heavier nucleus. In that moment of fusion, a tiny amount of energy was released, following a famous equation you may have heard of: energy equals mass times the speed of light squared. A small bit of mass became energy. This was nuclear fusion, the beating heart of every star and the ultimate source of light. Trillions upon trillions of fusion reactions erupted every second. hydrogen turned into helium. Energy poured out, driving temperatures up to tens of millions of degrees. The pressure from within, from these blazing reactions, pushed outward, fighting against gravity pulling inward. For the first time in the history of the universe, there was a force strong enough to resist gravity. The cloud stopped collapsing. It stabilized. It reached balance. A star was born. The first star had no name. It stood alone in the darkness, a solitary point of light in a vast, black ocean. But it was shining. It was releasing photons, particles of light, streaming out in every direction. Those photons carried a simple message through space: light had returned. For the first time in hundreds of millions of years, a true star illuminated the universe. This was not the faint, cold glow of the cosmic microwave background. This was new light, bright and hot, coming from a burning source. The universe had awakened from its long sleep. We do not know exactly what the very first star looked like. Its light faded long ago. It lived and died before our own solar system was ever born. But scientists can make educated guesses. Based on the conditions of the early universe and the materials available at the time, they believe the first stars were extraordinary. They were massive, far larger than our sun, and unimaginably hot. Their surfaces burned blue-white, dazzling and intense. Why were the first stars so enormous? Because the universe back then was very different from the one we see today. There was only hydrogen and helium. No heavier elements like carbon, oxygen, or iron. Those elements did not yet exist. Heavy elements play a crucial role in star formation. They help gas clouds cool down, collapse more efficiently, and form smaller, more stable stars. Without them, the gas clouds had only one path forward. They had to become very large and very hot. Only when they reached enormous size could gravity become strong enough to ignite fusion. So the first stars had no choice. They had to be massive. They had to be hot. They had to blaze. We call them the first generation of stars, the pioneers, the first torches in the dark. And these stars did more than shine. Deep inside them, in their nuclear furnaces, hydrogen fused into helium. Helium piled up in their cores. When enough helium accumulated, temperatures climbed even higher, and helium itself began to fuse, forming carbon. Carbon fused to create oxygen. Oxygen fused into even heavier elements. Layer by layer, step by step. The first stars became cosmic forges, creating new elements, elements that had never existed before. Carbon, the element of life. Oxygen, the air we breathe. Iron, the metal that flows in our blood. All of it was forged inside the hearts of the first stars. The first stars showed the way. They proved that light could defeat darkness, that creation could rise from chaos, that beauty could emerge from simplicity. And now, the real story begins. The story of stars, galaxies, and worlds that would be born from the work of these first blazing torches. The dark ages were over. The age of light had begun. By now, the universe was no longer home to just a few lonely stars. The first stars had paved the way. They proved that it was possible, that light could be born from darkness. Across the universe, in thousands, in millions of other places, more and more stars were waking up. Each one was a new lamp in the dark. But these stars did not emit only visible light. They released something else as well, something more powerful, more dangerous, and yet far more important. Ultraviolet radiation. Ultraviolet light is a form of light the human eye cannot see. It carries more energy than ordinary light. On Earth, we receive a small amount of ultraviolet light from the sun, enough to tan our skin, enough to make sunscreen necessary. But our atmosphere blocks most of it. In the early universe, there was nothing to stop it. The first massive stars poured out enormous amounts of ultraviolet radiation, millions of times more than the sun. That ultraviolet light streamed outward in all directions, racing through space at the speed of light. When ultraviolet light struck a hydrogen atom, something strange happened. You might remember that after recombination, hydrogen atoms were complete. Each atom had a proton at its center, with an electron orbiting around it. When ultraviolet light slammed into a hydrogen atom, it carried enough energy to rip the electron away from the proton. This process is called ionization, splitting an atom into smaller parts. Why does this matter? Because when hydrogen becomes ionized, the universe changes its nature. You may remember that during the cosmic dark ages, the universe was dim, not because there was no leftover background radiation, but because there were no new sources of light. There was another problem too. Even when light existed, neutral hydrogen tended to absorb certain wavelengths of it. It acted like a thin curtain, partially blocking what tried to pass through. Once hydrogen was ionized, it lost that ability. Free protons and electrons no longer absorbed light in the same way. Light could travel much more easily. The universe became more transparent, brighter, like wiping dust from a dirty window so light can pass through clearly again. This process unfolded slowly, over hundreds of millions of years. The first star awakened. Its ultraviolet light spread outward, ionizing the hydrogen around it, creating a small bubble of transparent space. At first, these bubbles were tiny and far apart. Between them, neutral hydrogen still filled the universe, keeping it murky. But stars kept forming. The bubbles kept growing. Ultraviolet light reached farther and farther. Gradually, the bubbles began to touch. They met, merged, and became larger bubbles. Early on, most of the universe was still dark, still filled with neutral hydrogen. Only small bright patches surrounded the stars. In the middle of the process, the universe looked like an abstract painting. Bright regions and dark regions intertwined. A picture in progress, not yet complete. By the end, most of the hydrogen had been ionized. Only a few small pockets of neutral hydrogen remained, tucked away in distant corners. So what was the result of all this? A completely different universe. Before, light struggled to move. It was absorbed and blocked by neutral hydrogen. The universe was like a dense forest, hard to travel through. Now, light could go far, millions of light years, billions of light years, without major obstacles. The universe became like a wide open plain, nothing standing in the way. Stars could see one another. Light from one star could reach another. Information could travel. The universe became connected. This was a huge leap. From isolation to connection. From darkness to light. From silence to communication. The first stars did not exist only to shine. They existed to transform the very environment around them. There is something beautiful about this process. The first stars, powerful as they were, could not change the entire universe on their own. A single star could ionize only a small region around itself. But when many stars acted together, when their efforts combined, they could change everything. It is a lesson in cooperation. Each individual doing its part, no matter how small, can lead to an enormous transformation when added together. Each star lit up a tiny corner. But millions of stars together illuminated the entire universe. The process of reionization marks a crucial milestone. It was the moment the universe moved from infancy into adolescence, from a simple, primitive state to something richer and more complex. Darkness was pushed back. Light won, not completely, not forever, but enough to change everything. From that point on, the universe would be a place of light, a place where stars could be born, live, die, and be born again in an endless cycle. Light is not something to be taken for granted. It is the result of a long struggle, of millions of stars burning themselves out, of hundreds of millions of years of patience. Every beam of light you see today, from the sun, from distant stars, from a simple light bulb, carries the legacy of that struggle, the legacy of the first stars that fought to push back the dark. We live in a world of light. But it was not always this way. It is a gift, a reward, a legacy. The first stars had awakened. They lived, they burned, some of them died. Their light spread across the universe. But they were still lonely, separated by millions of light years. In regions where dark matter was densely concentrated, where the cosmic web formed massive knots, many stars were born closer together. These stars began to feel each other's gravity. One star tugged another ever so slightly. The other pulled back. Both were moving, never standing still, but their paths slowly began to curve toward one another. Imagine a late night on a wide open field. You see distant lights scattered across the darkness, perhaps from separate houses. At first, they feel isolated, each light standing alone. But as you keep watching, you notice that some lights are closer together than others. Small clusters appear, 3 or 4 lights nearby, maybe a tiny village. The universe, at this moment, looked much the same. Here, 3 or 4 stars drifted close together. Gravity held them in place, and they began to orbit one another, like dancers moving through a slow, careful routine. Over there, a few dozen stars gathered into a larger cluster, a small village of light. Farther away, perhaps a few hundred stars had come together, a town in the making. These were primordial galaxies, the universe's first rough drafts, unfinished sketches. They looked nothing like the graceful galaxies we see today. No elegant spiral arms like the Milky Way. No smooth, rounded shapes. They were chaotic, shapeless, like uneven blotches of light against the dark. Like star clusters that had not yet figured out what they were meant to become. Some held only a few dozen stars, others a few hundred. The largest primordial galaxies may have contained a few thousand stars. That sounds like a lot, but compared to our Milky Way, with its hundreds of billions of stars, they were tiny. Toddlers just learning how to walk. These early galaxies had no clear centers, no organized structure. Stars moved along messy, unpredictable paths, with no simple order. They were like a swarm of bees in the air. Each bee flies its own way, yet the swarm stays together, bound by the gravity of the whole. Or like a late-night outdoor party. People wander freely, no assigned seats, but everyone remains close because that's where the lights are, the music is, the life is. Primordial galaxies that formed near one another began to sense each other's presence. Slowly, over hundreds of millions of years, they drifted closer. Some would collide and merge, becoming larger galaxies. Stars were forming faster now. Matter, enriched by earlier generations of stars, could more easily give birth to new ones. Each primordial galaxy became a stellar nursery. Clouds of hydrogen and helium, mixed with heavier elements, gathered and thickened. Gravity squeezed them tighter. New stars ignited. Their light made these young galaxies brighter, easier to spot from afar, like more lamps being lit at a growing party. Still, we cannot see the very first galaxies with our naked eyes. They are too distant, their light too faint after a journey of 13 billion years. But with our most powerful telescopes, like the James Webb Space Telescope, we are beginning to catch those faint traces from the universe's earliest days. We see tiny specks of light. Red, because their light has been stretched by the expansion of space. Dim, because they are unimaginably far away. But they are there. Each speck is a young galaxy, a first community of stars, a village trying to become a town. When we look at them, we are looking into the past. Back to a time when the universe was young. When galaxies were only just beginning to form. We are witnessing the universe's childhood. And in a way, we are not so different. We are born alone. But we find one another. We form families, friendships, communities. We build villages, towns, cities. We do this for the same reason the stars do. Because together, we are stronger. Safer. And our existence means more. The universe came with no instruction manual, no blueprint, no one to tell it how to build a galaxy. It could only learn by trying, by doing, by making mistakes, and then trying again. The only way primitive galaxies could become real galaxies was through a process that was chaotic, violent, and yet strangely miraculous. Over the next hundreds of millions of years, these early galaxies kept running into one another. Gravity pulled them closer. They drifted through space, each following its own path. Sometimes, those paths crossed. And when two galaxies drew near, something strange happened. They did not crash like billiard balls. There was no deafening explosion, no instant, crushing impact. Stars are simply too far apart. Even inside a crowded galaxy, the distance between stars is many times larger than the stars themselves. So when two galaxies meet, most of their stars just slip past one another, like two clouds of mist passing through, with actual star-to-star collisions being incredibly rare. But even without direct collisions, their gravity interacts fiercely. As two young galaxies begin to pass through each other, the gravity of one tugs on the stars of the other. Stars are yanked out of their original orbits. They start flying along new, strange curves. Some are pulled toward the other galaxy. Others are flung far away. It is like two crowds of people walking in opposite directions down a busy street. They do not slam into each other, but they sidestep, weave, change direction, push past. The original order dissolves. Galaxies behave the same way. After an encounter, their original structure is disturbed. Stars no longer follow neat, orderly paths. Everything turns chaotic. But the most dramatic changes do not happen to the stars, they happen to the gas. Primitive galaxies are rich in gas, hydrogen, helium, mixed with traces of heavier elements. Vast clouds of gas drift between the stars. When two galaxies collide, their gas clouds do not pass through each other like stars do. Gas is thicker, denser. Its particles slam into one another. When gas collides, it is compressed. Pressure skyrockets. Temperatures climb. Friction generates heat. These enormous gas clouds crash together at hundreds of kilometers per second. The impact creates shock waves. Those waves race through the clouds, squeezing the gas, making it denser, hotter. When the gas is compressed enough, it begins to collapse into smaller clumps. Those clumps keep shrinking. Their gravity grows stronger. Temperatures rise even further. Eventually, at the cores of these compressed clouds, conditions become extreme enough to ignite nuclear fusion. New stars flare to life, dozens, hundreds, thousands of stars igniting almost at once. This is a starburst, a furious, rapid, intense wave of star formation. Galaxies going through this process are called starburst galaxies. They form stars tens, sometimes hundreds of times faster than normal. In a calm galaxy like our Milky Way, about 1 to 3 new stars are born each year. A steady, slow, sustainable pace. But in a starburst galaxy, hundreds or even thousands of new stars can be born every single year. The light from these newborn stars makes the entire collision region blaze. From afar, it looks like a colossal fire burning in the depths of space. These young stars, born in chaos, are usually massive, extremely hot, and incredibly bright. They shine with intense blue-white light. They blast powerful stellar winds, pushing surrounding gas outward. Some live only a few million years before exploding as supernovae, scattering heavy elements into their surroundings and enriching the environment. But the chaos does not end there. When galaxies collide, gravity does more than scramble stars. It drags them into strange directions. Some stars are pulled far away, stripped from their original proto-galaxy. They form long streams, chains of stars stretching tens, even hundreds of thousands of light years. We call these structures tidal tails. Like ocean tides on Earth raised by the moon, but on a cosmic scale. These tails look like flowing ribbons, glowing strands, pulled out from colliding galaxies. They curve, twist, and coil into breathtaking shapes. Every point of light in those tails is a real star. A star torn from its home, now drifting through space, far from where it was born. Tidal tails are not just beautiful. They are evidence. They tell a story. When we see a galaxy with tidal tails, we know immediately that it has collided with another galaxy. Those tails are scars of the encounter, traces of chaos. Some tails stretch for hundreds of thousands of light years. They contain billions of stars. Each one carries its own story, its own journey, from a once peaceful young galaxy, through a violent collision, now floating in the void. Some of those stars will eventually fall back into the main galaxy. Gravity will slowly pull them home. It may take billions of years, but they will return. Others will never come back. They will wander through space forever, lonely and distant, like eternal travelers. Galaxy collisions sound violent, chaotic. And they are. But they are not destruction, they are creation. From the chaos of collisions, thousands of new stars are born, stars that could never form in quiet conditions. From gravitational upheaval, small galaxies merge into larger, stronger, more complex ones. From tidal tails, matter is redistributed, spread outward, creating new opportunities for formation in distant regions. This is how the universe builds, not with careful precision, but through experimentation, collision, and merger. Like a sculptor who does not only gently smooth clay, but strikes it, presses it, forces it into shape. Like a chef who does not merely stir softly, but beats and kneads vigorously to create the perfect texture. The universe does the same. It builds through chaos, through collision, through what looks like destruction, but is actually creation. And we, as humans, experience collisions in our own lives. Moments when everything changes suddenly, when plans fall apart, when we meet new people, new ideas, new challenges, and life is never quite the same again. Those moments can feel chaotic, even violent in an emotional sense. We feel lost, like stars thrown out of orbit. But sometimes, from those collisions, something new is born, new ideas, new relationships, new versions of ourselves. Collisions are not always bad. Sometimes they are the only way to create something bigger, more beautiful, more complex than what came before. The universe teaches us this lesson through colliding galaxies, through sweeping tidal tails, through furious starbursts. Chaos can be the beginning of beauty. After billions of years of collisions, mergers, and star birth, galaxies began to settle down. They started to find their shape. It is astonishing that from the same basic ingredients, hydrogen, helium, dark matter, gravity, the universe did not create just one kind of galaxy, but many. Like flour, water, and yeast that can become bread, pizza, or cake, each with a different shape, texture, and flavor. The universe works the same way. It is a creative artist that never repeats itself. Every galaxy is a unique masterpiece. Let's explore those masterpieces together. The first type of galaxy we'll talk about is the one most familiar to us, because we live in one. The spiral galaxy. When you think of a galaxy, the first image that probably comes to mind is a beautiful spiral, a flat disk with curved arms winding outward from the center, like a gigantic cosmic whirlpool frozen in space. Centrifugal forces flatten it into a disk. The result is a rotating, pancake-like structure. At the center is a bright region called the core. Surrounding it are spiral arms stretching outward. Our Milky Way is a spiral galaxy. We live in one of its spiral arms, about a third of the way from the center to the edge. Those spiral arms are not solid structures. They are not actual arms rotating along with the galaxy. Instead, they are waves, density waves, regions where stars and gas are packed slightly more tightly together. Stars move into a spiral arm, then out of it. But the spiral pattern remains, like a wave traveling through the galaxy. When gas enters a spiral arm, it gets compressed. When compressed, it begins to collapse, forming new stars. That's why spiral arms glow so brightly. They are filled with young, hot, luminous stars. Spiral galaxies are stunning. They are vibrant and colorful. The arms shine blue and white from young stars. The regions between arms can glow pink or red from clouds of ionized gas. The center often appears yellow or orange, where older stars gather. They contain plenty of gas and dust, dark lanes where dust blocks the light behind it, and bright regions where new stars are being born. Spiral galaxies are star factories. They are still actively forming new stars. Each year, a few new stars appear, not many, but steadily and continuously. The Milky Way forms about 1 to 3 stars per year. That is a normal rate for a medium-sized spiral galaxy. But not all galaxies are this lively. There is another type of galaxy, quieter, older, and more stable. The elliptical galaxy. Elliptical galaxies have no graceful spiral arms. They lack complex shapes. They are simply rounded blobs. Some are nearly perfect spheres. Some are slightly flattened, like a rugby ball. Some are stretched out, like a peanut. But they all share one thing: they are not flat, they have no disk, no clear top-to-bottom structure. Stars in elliptical galaxies move on random orbits. Some go this way, some that way, some up, some down, without the organized rotation seen in spiral galaxies. It's like a swarm of bees. Each one flies in its own direction, but the swarm stays together because gravity holds it in place. Elliptical galaxies often form through major collisions. When two spiral galaxies collide, especially if they are similar in size, their spiral structures are completely destroyed. Stars are thrown onto chaotic paths. Gas is blown away or consumed in intense bursts of star formation. After the dust settles, figuratively speaking, what remains is a large collection of stars moving in random directions, an elliptical galaxy. Many of the largest elliptical galaxies in the universe formed through repeated mergers. They have eaten many smaller galaxies and grown over time. The colors of elliptical galaxies are different from spirals. They are usually yellow or orange, sometimes slightly red, without bright blue tones, because they lack young stars. Most of their stars are old. They have existed for billions of years, burning slowly and steadily, giving off warmer light. Elliptical galaxies also contain very little gas. Most of it has already been used to form stars, blown away during collisions, or pushed out by energetic processes. Without gas, there is no raw material for new stars. As a result, elliptical galaxies form very few stars. Maybe one every few years, or none at all. They are in the retirement phase of a galaxy's life. No longer energetic. No longer bustling. But still stable, still enduring, still beautiful in their own way. There is something peaceful about elliptical galaxies. They have survived countless battles, collisions, and upheavals. Now they rest, quiet and calm, enjoying old age. Elliptical galaxies remind us that not everything needs to be busy or active. Sometimes, quiet itself is a form of beauty. But not all galaxies fit neatly into those two categories. There is a group of galaxies that follows no rules, with no clear shape, not spiral, not elliptical, not anything familiar. We call them irregular galaxies. Irregular galaxies look like someone grabbed a handful of stars, crumpled them up, and tossed them into space. They have no clear center, no spiral arms, no symmetry. Just scattered patches of light, clusters of stars arranged in strange ways. Some look like spilled ink. Some like torn fabric. Some like shapeless clouds. Why do they look this way? Some irregular galaxies are young. They have only recently formed and haven't had time to settle into a stable shape. Like a toddler learning to walk, still unsteady, still wobbling. Others once had beautiful shapes, maybe spiral, maybe elliptical. But they suffered an accident. Perhaps they passed too close to a larger galaxy, whose gravity pulled at them, stretched them, and distorted their form. Or they collided with another galaxy, but not hard enough to fully merge. Just enough to scramble their structure. Now they are trying to reorganize themselves, but they are not there yet. Some irregular galaxies live in crowded regions, where many galaxies are packed together. Gravity tugs at them from all sides, never allowing them to settle into a single shape. But don't underestimate irregular galaxies. They may not be as elegant as spirals or as calm as ellipticals, but they are full of energy. Many irregular galaxies form stars at a furious pace. They contain large amounts of gas and raw material. Gravity pulls that gas together, compressing it and continuously creating new stars. Some irregular galaxies are small but incredibly bright, like tiny diamonds, dazzling and full of life. They are the rebels of the universe, refusing to follow the rules, rejecting standard shapes. And because of that, they are fascinating. They remind us that not everything needs to fit into a mold. 3 main types of galaxies: spiral, elliptical, and irregular. Each with its own beauty. Each telling its own story. Spiral galaxies are young artists, still creating, still producing new works. Elliptical galaxies are wise elders, having experienced much, now resting in peace. Irregular galaxies are free spirits, unbound by rules, living on their own terms. All of them are made from the same ingredients: hydrogen, helium, dark matter, gravity. Yet from those ingredients, the universe has created endless variations, each unique, each special. That is the power of creativity, of diversity, of beauty in difference. And despite their different shapes, all galaxies share one thing. They are all part of a vast cycle, a grand process of endless renewal. After drifting through the vast universe, after witnessing the birth of the very first galaxies, it is time for us to return to a familiar place. Home. Our home is not a planet, not a solar system, but a galaxy. A colossal city of stars we call the Milky Way. This is where every human story has unfolded. Every civilization, every discovery, every dream. All of it happened here, inside our galactic home. So let us take a closer look at this place. The Milky Way is a spiral galaxy, like the beautiful galaxies we see in images, with elegant, curving arms winding through space. But there is one small problem. We cannot see its full shape from the outside, because we are inside it. It is like trying to read a bottle's label while sitting inside the bottle, or trying to see an entire building while standing in one of its rooms. We are inside the Milky Way. We are part of it. So we can only see it from an internal point of view, looking outward in all directions. When you step outside on a moonless night, far from city lights, and look up at the sky, you will see a faint, misty band stretching across the darkness. We are looking sideways through the disk of the galaxy, through its densest region, where stars are most crowded. The light from all those stars blends together, forming that soft, glowing band. When you gaze at that pale ribbon of light, you are looking into the heart of your galaxy. You are looking through billions of stars, through clouds of dust, through history itself. The Milky Way is big. Truly big. Its diameter is about 100,000 light-years. 100,000. It sounds like just a number, but try to grasp what it means. A light-year is the distance light travels in 1 year. Light moves at about 300,000 kilometers per second. In a single year, it travels roughly 9.5 trillion kilometers. Now multiply that by 100,000. That is the diameter of our home, a distance the human mind struggles to comprehend. Even if you traveled at the speed of light, the fastest speed possible in the universe, it would still take you 100,000 years to cross the galaxy from one side to the other. Inside this immense space, how many stars are there? We do not know the exact number. It is very hard to count when you are inside, looking through obscuring dust clouds, trying to tell one star from another. But scientists estimate somewhere between 100 and 400 billion stars. Why such a wide range, from 100 to 400 billion? Because counting is incredibly difficult. Many stars are faint and small, hard to detect. Many are hidden behind dust. We can only estimate. But whether it is 100 or 400 billion, the number is still overwhelming. It is more stars than grains of sand on a large beach, more than leaves in a forest, more than almost anything we can count in our lives. Among those hundreds of billions of stars is one we call the Sun. A small, yellow, ordinary star. Not particularly special compared to others. Not the biggest, not the brightest, just one among billions. But to us, it is everything. Because it is our star. It warms the earth. It gives us light. It is the reason we exist. The Sun, along with Earth and all of us, lies within one of the Milky Way's spiral arms. That arm is called the Orion Arm, named after the constellation Orion, the hunter from Greek mythology. Our position in the galaxy is rather special. We are not at the center, and we are not at the outer edge. We sit in between, about 1/3 of the way from the center to the rim. About 26,000 light-years from the center, in a galaxy 100,000 light-years across. It is a perfect spot. Not too close to the crowded, chaotic center, not too far out. Much like Earth's position around the Sun, not too hot, not too cold, a habitable zone. We live in the galactic suburbs. Not the bustling downtown core, and not the lonely countryside, but a quiet, safe neighborhood, just right. From our position, when we look up at the night sky, what do we see? We see individual stars, the ones closest to us, within a few hundred or a few thousand light-years. They are close enough for us to distinguish them one by one. We see the faint band of the Milky Way stretching across the sky, the combined light of billions of more distant stars blending together. We see dark patches, not empty space, but vast clouds of dust blocking the light behind them. We see bright regions, places where new stars are being born, where gas is collapsing, where young stars are igniting. Everything we see with the naked eye is part of our own galaxy. There is not a single star visible to the unaided eye that belongs to another galaxy. Every one of them is a neighbor in the same star city. There is something profound about knowing that every star you see is part of the same community. We are not alone. We are surrounded by billions of other stars. Some have their own planets. Some may host life of their own. All of us, all those stars, are orbiting the same center. All are members of the same galaxy. All share the same past, and the same future. Yet from inside, we cannot see its full, beautiful shape. To do that, we would need to fly outward, beyond the galaxy, and look back from afar. We cannot do that with spacecraft. The distances are far too great. But we can do it with imagination, with science, with careful observation. Scientists have mapped the Milky Way by tracking the positions of stars, measuring their motions, analyzing their light. From all this information, they have built a picture of the entire galaxy. According to these maps, the Milky Way has 4 or 5 major spiral arms. The Orion Arm, where we live, is actually a smaller arm, a minor branch between 2 larger ones. At the center lies a long bar, a rectangular structure of stars, with spiral arms extending from each end. Seen from above, the Milky Way would resemble a gigantic whirlpool, frozen in time, beautiful, balanced, breathtaking. A large spiral galaxy. One among hundreds of billions of galaxies in the universe. But to us, it is unique. It is special. Because it is where we were born. Where all our stories unfold. Where we look up at the night sky and wonder about our place in the cosmos. There is something magical about realizing that we do not just live on a planet, in a solar system, but are members of a galaxy. A vast, ancient, beautiful city of stars. Every time you look up at the Milky Way in the night sky, remember that you are looking at your home. At your community. At your stellar family. You are part of something far greater than yourself, part of a cosmic masterpiece. If you enjoyed this journey, leave a line in the comments. Just a few words. Where you are. How you feel. I love reading them. Tap like if you want more people to find this journey. Subscribe if you would like to drift through the universe with me again in the future. There are many more stories to tell. Many more journeys to take. Many more wonders of the cosmos waiting for us. But for now, it is time to rest. Let the stars keep turning. Let the galaxy continue drawing its spirals. Let the universe carry on its grand journey. And you, sleep well. Dream of distant galaxies. Of unnamed stars. Of worlds yet to be discovered. They are out there, waiting. As they always have. As they always will. Good night, fellow traveler. Wanderer of the galaxy. We will meet again. Under the stars. In dreams. Among the stories of the universe. Until then, rest. Be at peace. The galaxies will still be there when you wake up. They always are. Always. Sleep well, in the arms of the stars.